Now, I think at this point, it's probably helpful for us to see these iterations in action just to make sure that they still work inside of our a red-black tree and to be able to actually see the tree in a bit more detail. So I'm going to implement all of the different iterations that we had previously, and I'm just going to show you, relatively quickly how these generally are going to work, right? So this is really just kind of a review. So if you remember, our in order was going to take a look at the tree actually in the order of nodes, right? So it's going to actually keep things like in sorted order. Basically, all that really changes here between the binary search tree and this one is instead of looking for none, we need to look for self.nil. And then we just do our in order auxiliary on root.left. We then print root.value. We then do the in order auxiliary on root.right. Right, so that's all there is to it. And now I can do this print for in order, and we can actually see all the data inside of our tree, right? So if I go ahead and run this here, you'll see 1, 2, 3, 4, 5, right? So all the data made it into the tree, and we can still print it out in sorted order. We do the exact same thing with all of our other traversals. I'm not going to take too much time on them because, you've already seen these in action. They're basically the exact same as what they were, just that this root condition basically changes. So pre-order auxiliary, again, is going to take a look at printing first, like this. Right, so that one's a nice and easy one. And then the post order is going to be a similar kind of story, right? So if we do post order and we do, the post order aux, right? Basically what ends up changing here is we end up printing after the iteration, right? So we just move this to the end here and we are good to go, right? The one that I'm a bit more interested in talking about is the level order traversal, right? Because the level order traversal actually lets us see a bit more of the detail around our actual tree itself. So remember, with the level order traversal, what we do is we say if self.root is equal to nil, right? Self.nil, then we just return. Otherwise, what we do is we create a queue and we onqueue self.root, right? And then we say while the queue.size is greater than 0, we are going to dequeue, right? So we dequeue, we print the value, and then we say if node.left is not equal self.nil, then we onqueue node.left, and then if node.right does not equal self.nil, then we onqueue right node.right, like this. There we go. So that's the way that we generally have this. Now I need to import my queue, and I do have it here, so I can go ahead and import it for myself here. So I could say from node queue import queue, and that should be all I need to get this up and running, right? So let's take a look at this to make sure that it actually works. And you'll sort of see why the level order is helpful for us to have, because it shows us more of the actual balancing of the tree itself. So if I take a look at this with chapter 8 node.py, do you see, so the root is 2, right? And then we have 1 and 4 below it, and then we have 3, 5 directly below that. So we actually see this in the level order. And we can see that the levels are fairly evenly distributed, right? So it helps us understand a little bit more about the actual structure of the tree itself, right? And allows us to be able to see exactly where each level of the tree is in terms of our insertions, right? So you can see a bit more in action how that's actually working in terms of the balancing of the tree on the actual inserts themselves. So that gives you your different iterations, which are, again, fairly straightforward if you remember the binary search tree iterations. And in the next video, we're just going to finish off our red-black tree by taking a look at deletions on the structure. So thanks so much for watching. I'll see you in the next video.